Hello everyone and welcome to today's webinar on our EHCD modules. My name is Dimitri Levitt and I'm the National Development Manager for Automation Control and Industrial IoT for HYDAC Australia. Thanks for making the time to join us today to talk about these clever devices, and I hope you enjoyed. If you have any questions, please make sure to post in the questions tab and we'll endeavor to get back to you, endeavor to answer all of them towards the end. So today we'll talk about our EHCD modules and what we call electro-hydraulic control devices. And effectively, they're control modules for electro-hydraulic systems. So on today's agenda, we'll go over what are EHCDs, some of the application and use cases, our parameter configuration tool, which I think is really, really nice tool for customizing and configuring these modules, and our range of modules that we have available. So EHCD, what are they? It's a configurable control device for electro-hydraulic systems. And it comes in different types. So we have a simple power amplifier, so like the one shown there, the little plug, that can just sit directly on the valve and produce the PWM signal. We also have general control modules for interfacing with PLCs via 4 to 20 signals, and I'll explain more about how these modules work, to closed loop controllers and to specialized synchronized or position controllers. So our EHCD range. We have quite a broad range of devices. So first of all, we have our analog device here. And by analog, I mean you configure it using potentiometers, as you can see on the front of the screen. And we have our digital parameterizable and programmable devices. So for example, we have our PWM amplifiers. We have special pressure, force, and flow controllers. We have position and synchronization modules. And we have also Profibus and Profinet options. I've grayed out the analog module. It's a simple module to use, but it doesn't offer a lot of customization. You have to configure it using potentiometer, so it may not be the best option for certain applications. And we recommend you go for our digital range, especially the one that I'll focus on. So we'll go over some use cases. First of all, before you start and before you apply one of these, it's important to read the documentation, in particular the safety information, to see if these devices suit your application and meet all the safety criteria that you're trying to use these for. So use cases, when would you use one of these modules? So one of the ones that comes to mind is when you have a simple automation system, you don't have a PLC, for example, and you need complex closed loop control. You do closed loop control on pressure and flow and force, or a PLC without power stages. I'll go into that a bit more. And when you need to do synchronization and position control. So use case one, we'll have a look at the simple but complex scenario. So you have a system already and you need to control, you need to do closed loop control, but you don't really need a lot of automation or sequencing or anything like that. You may not have the availability of a PLC, or the PLC functions are limited. And again, you need to perform really, really precise closed loop control. So in this scenario, one of the EHCD module is a really, really good option. I'll explain why, and I'll go into a lot of depth into how these modules work. So one of the benefits of these modules, we have different types. So for example, you select the module for that particular application. Within the module, you can program it and configure it using the parameterization software, which I'll go into. You have a really nice handy reference voltage output. So for example, if you want to control something with a potentiometer, you already have a really good stable output that you can power your potentiometer from. We have analog inputs, and you can do 4 to 20 or 0 to 10 volt. You can scale those analog inputs using the parameterization software. So again, you've got the option, you need to do something complex, but you don't have a PLC. This is a really good option for you. Within the software result, you can customize your ramps. You can do linearization if you have a coil or a valve that's not responding linearly. You can limit your outputs. You can, for your actual valve, control the limitation. We have a power stage to perform the PWM valves, to perform the PWM signal to the valve. As most of you know, most hydraulic valves are operated using a PWM signal with a constant frequency and a varying duty cycle. So these modules produce that PWM signal and vary the duty cycle. And then this is a really nice feature. We have the enable input for, if you have two valves, we have an enable input for valve A and enable input for valve B, or coil A, coil B. This is really good if you have interlocks in the system. That means until these interlocks are met, the valves actually won't turn on. So once you enable these signals, you'll get an output status coming up and you'll have power to your valves, and your valve will actually move. So this is a really, really good option if you need to perform ramps, customize how long things are, it's certain for times, ramp up, ramp down, limit the current going to the valve. This is really, really good application. So the other potential is you already have a PLC in your project, but the PLC doesn't have a PWM output. So if you need a PLC, generally PLCs have 0 to 10 volts or 4 to 20 milliamp outputs, and when you try to put that onto a PWM valve, nothing happens. It won't work. Obviously, unless there's a valve that has onboard electronics, in this scenario it'll work. But if you have a valve that only takes a PWM signal, for this scenario it won't work. So the solution is to put an EHCD module in between, take the 4 to 20 milliamp signal from the PLC, scale your input, and the module will produce the PWM output and drive your cylinder or drive your motor, pump, whatever it is you want to control using that EHCD module. Another application or use case is if you really need precise closed loop control. For example, you really need to control pressure, and you need to control the pressure or the pressure or the force you're applying to a system very accurately. These modules are a really good option for it, because as you can see, you can attach a pressure sensor and it'll feed back straight in to control the cylinder. And within the module, there's a lot of really nice features for PID control and PID tuning, and they're really optimized for these sorts of applications. Another thing, you can remove this functionality from the PLC and just have it standalone on the module. So for example, an application here is if you need to apply constant force or onto, if you want to straighten some iron, straighten some sheet, or for a press or something like that. So you can use it here. Really good application. So so you don't have to write the logic in the PLC for this type of application in the PLC. You can leave it up to the EHCD module, and it's designed to do this. This is what it's designed to do. Another application or another use case is if you really need to do position and synchronized control. So, for example, you need to move multiple cylinders at the same speed or in the same time. We have modules specifically for that, or you need to drive constantly to a specific position. You can get cylinders that have position sensors inside, and you can run the feedback of this analog signal directly into the EHCD module, and then just control the position. For example, in timber mills, you need to drive saws to particular positions repeatedly, like constantly, and then move it to another position. Really good option to let the device can perform its own PID control, and it'll control it really precisely. Or you have synchronized moving. I really want to go into our parameter configuration software, which is, I think, a really nice tool. So we get a lot of requests for PLC projects and things like that, but a lot of the times these modules can actually perform the function of what a PLC could do if you don't have complex automation requirements. So the software is free, and it's available to download from the HYDAC website. So you can go to hydac.com/de-en. Hopefully it comes up in English for you. Click onto downloads, software and systems engineering, and you'll be able to actually download the software. And then once you connect the module here, you'll be able to via the USB port, you'll be able to configure it. So as you can see, these devices are actually quite small. So yeah. Now we're looking at the parameter configuration software. So once you've got your device connected, it'll appear with all the settings possible for that particular device. And the nice thing is it's really, really easy to use. It's a table-based input, so all the options are listed there for you, and they correspond to the manual of the device. So for example, we have the analog input scaling, really nice feature if you want to chop your analog signal. There, just some of the scaling there. And this is also for the ramp time. So again, you can customize your ramps for this particular application. So for example, maybe you need to extend the cylinder over 5 seconds and then pull it back in faster or slower. You can do that with a ramp time. So you set it in, and it controls to that. We have your limitation for the current of the actual valve. So on the data sheet of the hydraulic valve or the coil that you use, it'll actually say what the maximum current is, and you enter that information there from the data sheet here. We have dither options. So if you are controlling at really high frequencies, we also have dithering available for those really high frequency valves if required. Plus, you set your PWM frequency, and that's also comes from the data sheet. So when you're setting these values up, you'll be looking at the data sheet of your coil, of your valve, and setting them up here. Again, table-based input, really, really simple. And we have your PID settings, and plus there are further settings available. The other main thing is you can save these settings and deploy them onto multiple devices. For example, you know, when I removed the device that had those potentiometers at the front with a screwdriver, this allows, those become very difficult to repeat. With this type of module, with the digital ones, you can actually just save and copy the settings. So it makes it a lot easier. The really, really nice feature I like within the software, it has a oscilloscope function. So you can see what's happening in the real world based on your settings. So for example, here we have the P command. So we actually have the required output. We have what's actually being transmitted from the controller, like the PID value, the control value. We have the current feedback from the solenoid, as you can see there. And you can see the ramps. So we've configured ramps, put in the command to go to, let's say 50%. You can see how the ramp, the PID controller is outputting the value, the current feedback from the solenoid, and you can see how the solenoid is actually responding with the current as well. So really, really, really nice function for you to be able to do that and see what's happening with the controller, with the module and in your physical system. The other really nice feature is we have a live view remote control mode, as we call it. So, for example, if you have configured the device, you have the cylinder or something there ready, you can drive it manually. Again, please note that once you're in this mode, all the safety functions, you're controlling the valve directly, so things will move when you start playing with it here. So just be mindful. This gives you a really nice way to actually test to see if your PID is responding correctly, whether it's the control, whether it's there's an issue with the hydraulics or an issue with the control loop or something like that. So really, really nice features. So, and again, the software is free, really easy to use and explained quite well because it all links in directly with the manual of the device you're going to use. So I want to go into the range, a bit of a deep dive into the different types of modules we have. So here we have our universal plug amplifier. So what this device does, it sits directly on the valve coil, and you send it a 4 to 20 milliamp signal, and it'll produce the PWM output directly onto the valve. So really, really handy, really tiny device. Again, it's also programmable using the same software. We have iLink options available too, but yeah, really nice to use. You have to use on the bottom left, you have a USB configuration tool, but also takes in a 0 to 10 volt input. You can program in ramps, your min-max scalings. It has the power stage to produce the PWM signal, and it obviously controls one coil. So a bit of a block diagram with the iLink one. So you're also able to, these are available with iLink, so you can control, if you have an iLink master, you can send the required commands through iLink instead of 4 to 20 milliamp signal. So now we'll go into our universal digital amplifiers. So this is probably the one that's going to be common to a lot of applications that are out there, in particular this device. So as you can see, you can control 1 or 2 valves directly. It can be controlled by analog or digital inputs. So customization using parameters, ramps, and like frequencies and things like that. 4-quadrant ramps as well, as I mentioned, so you can choose how quickly you want things to scale up and scale down. And one of the really nice features with the software, again, is you can linearize your solenoid if it isn't performing linearly. So as I mentioned, you can control this using digital inputs or analog inputs. So for example, in this example here, we have the digital inputs. So we have 3 digital inputs that are going in to the module, and you can have up to 8 pre-programmed command and ramp values. So this is what some of the settings are options. So obviously, if you have 3 inputs, you can have up to 8 different, when you 3 bits, when you work that out, that gives you a value of 8. So you can have 8 different settings. And generally, you can use this for in conjunction with recipe controllers and things like that. So you have a recipe controller, it'll produce a binary coded decimal output, and it can control this device. So it's quite a flexible little module. The same module also has the ability, so you change the function within the module. You can control one directional valve using a 0 to 10 volt, 4 to 20, or minus 10 to 10 a volt signal or a potentiometer. So you choose your ramps, your scalings, and it'll produce the output to the valve, drive it backwards and forward. They are the same module, depending on the function you choose. You can actually use it to control two different valves independently, and each one of them can have its own ramps and min maxes and inputs. So really nice option there. So quite a jack of device that's usable for a lot of different options. So internal block diagram, as I've showed you before when I went into the use case one, but it gives you a lot of options. This particular device, off the shelf, can do quite a lot and can be used for a lot of different applications. So one of the more specialty modules is our pressure control modules. So it's designed for really accurate closed loop control. So if you really need to control force accurately, pressure accurately, we also have other ones which are Q and P, so flow and pressure control. We have iLink coming soon in this module as well, which will be end of 2021. And the iLink modules you'll be able to control 2 pressure loops and full feedback monitoring via iLink. So internal block diagram of what it looks like. Your PLC input will be a 4 to 20 or a 0 to 10 volt. As you can see, you've got a pressure sensor. The pressure sensor feeds back into the input of the EHCD module. You have a PID loop or configure there, your min-max scalings, and it'll hold it as well. So it'll hold it accurately. We also have high accuracy analog input modules. And as I mentioned, we have a lot more other special modules available, such as flow and pressure control. We have positioning modules. So if you need to drive a cylinder to a particular position, hold it there and move it backwards and forwards when required. We also have ones that have SSI feedback, so special feedback from some sensors, linear position sensors, which are installed inside the cylinder, can feed directly back into this module, and you can do acceleration and deceleration control. So what it looks like as a block diagram, again, you have your input coming in as a speed or a position. You can set up your control functions using the same parameterizables, using the same software. The module sends a signal to the cylinder, and the cylinder moves with the feedback coming back into the controller, into the module. And we have these also available with Profinet and Profibus. So, and you have full feedback monitoring with the set point value, the actual values, control errors, and feedback of the sensors. So, and you can achieve really high accuracy with 0.001 millimeters using the SSI sensors. Again, as I mentioned before, you can control the acceleration and deceleration of these modules. Another really cool one, for example, if you need to lift up a working platform and you have 2 cylinders, is we have synchronization modules. So we have one main module, and you can synchronize up to 4 different cylinders directly. So, and you can have control and feedback via Profibus. So you have the Profibus coupler. It'll connect to the other modules, which will control their own cylinders, and it'll sync up the movement using a master-slave methodology. So again, really nice feature if you have complex motion control requirements, and to be able to, it might be more difficult to program, for example, if you have a PLC, but if you have one of these modules, it does the control for you. So to summarize, these modules are quite flexible, they're easy to use, and you can apply them in a lot of different applications, as I mentioned before. One of my favorite applications would be one if you have a simple system, but it requires a complex closed loop control, as mentioned before, because you have a lot of options. You have the device, you can select which type of device you have, which function it's going to use. You can configure it using the software. You have a range of input options. You can choose your ramps. You can choose your linearization, your scalings, and it comes with a power stage. Interlocking as well, so you can tell it when to start and stop, and feedback to control the coils. So thank you very much for your time. Thank you for joining me to talk about these little EHCD modules. If you have any questions, please feel free to contact me or at us at info@hydac.com.au. Thank you very much.